Hey everyone, welcome back to Solving Equations Day 2. So yesterday we looked at how you can solve equations with a bar model and how you think about your equation as a balance. That the equal sign is where your equation balances and the stuff on this side has to have the same value as the stuff on this side. So if I looked at this equation, I would think, okay, x plus 4 needs to balance with 7. That means x has to equal 3. And that's the solution to my equation. Now, this is one way to think about solving equations, but as we move into more complicated equations, it's difficult to draw them out like this. So we come up with another method. And that method is called solving equations using inverse operations. And that's what we're going to talk about today. When we're solving an equation this way, we're thinking more about an equation as a present, where our variable is what's inside of that present, and we need to unwrap it to figure out how much that variable is worth, what value is inside. And the things that are wrapping up our variable here are our operations. So it can be adding or subtracting or multiplying and dividing. Those are the things that are happening to my variable that I have to undo to figure out its value. So that's my goal, undo the operations to unwrap the present. Well, how do we undo operations? If I see a problem that has adding going on, how am I going to undo it? So we like to think about our inverse operations as how we can undo our operations in an equation. So the inverse operations are things that we already know. Adding is inverse to subtracting. They undo each other. They're kind of the pair that go together. And so we're going to think them as anytime we see adding, we're going to undo it with subtracting. And anytime we see subtracting, we're going to undo it with adding. The other pair of operations that we have are multiplying and dividing. And they also undo each other. If we see a multiplying happening, we're going to divide. If we see dividing happening, we're going to multiply. And so those are our inverse operations, and that's how we're going to unwrap these presents of our equations to find our variables. When we're working with inverse operations and we're undoing things, we also need to think about what order we'll undo things. So just like with a present, you can't take off the wrapping paper unless you've undone the bow first. The same sort of thing happens with an equation. To figure out which operations come first when we're undoing them, we need to think about our regular order of operations. Today I'm going to call it PEMDAS, while we all know that this is really GEMDAS. So if I were simplifying an expression following the order of operations, I would go in PEMDAS order. I would do all my parentheses before my exponents, my multiplying before my dividing, my adding before my subtracting. But when I'm solving an equation using inverse operations, I'm actually going to go in the inverse order. I'm going to go in backwards order. I'm going to go SADMIP. That means I'll always undo any subtraction or addition before I undo any multiplying or dividing. So I'd have to do subtracting or adding first, or multiplying or dividing, and multiplying and dividing second. So let's see what that looks like. Down here we have our first equation. 4x plus 5 equals 7. And looking at my equation, I see here is my variable, and that's the thing I want to unwrap. I want to find its value. So to do that, I need to think about what operations are happening to x. Well, x is directly next to 4, so that means they must be being multiplied together. And then what's happening is then we're adding 5. And all of this stuff balances with 7. I need to unwrap these two operations. So to unwrap or undo times 4, I'm going to divide by 4. And to unwrap adding 5, I'm going to subtract 5. Next, I have to think about the order I'm going to do these two things, which comes first, which comes second. For that, I go in SADMAP order. So I want to subtract before I divide. So let's see this in action. Below my equal sign, I'm going to draw a line. And that's the line just separating the two sides of my equation, the two sides of my balance here. Well, like we talked about yesterday with our actual balances, what you do on one side of the equation, you have to do to the other. So I draw this line here to show the both sides of the equation that I'm going to do my operations on. I look at my operations, my plan over here, and my plan was to subtract 5 from both sides. So that's pretty easy to do on this side. There's only one number to subtract 5 from. But over here, I'm going to subtract 5 from the constant part, from the 5 here. When I do this, these two 5s cancel each other out. I have 5 things on the balance, I take 5 of them away, I'm left with 0 things from here. But I still have my 4 x's. On the other side of my balance, I have 7 minus 5 is 2. I have simplified my equation here. Now I'm down to one term. So see, I've taken off the bow of that wrapping paper because I've completed that step. My next step is to divide by 4. So I'm going to divide both sides of my equation by 4. When I'm solving an equation, I like to use a fraction line for division. Because I think it makes my answer look a little clearer. And when I do so, sometimes I'm left with a fractional answer, it's already there. So if I take 4 x's and I divide by 4, times 4 and divide by 4 cancel each other out. I'm just left with 1 x. On this side, I'm left with 2 divided by 4. Well, 2 divided by 4 is not a whole number, it's actually a fraction. It's 1/2. So my value of x has to be 1/2. We always talk about how when we come up with an answer, we think we're done, we'll circle it, but we should go back and check it. Because if the x is 1/2, if we did everything right, then 1/2 would be the value that would balance out my equation. So to check my answer, I'll go over to the side here. And I'm going to fill in 1/2 for x. So what was happening between 4 and x? Oh, that was being multiplied. So I'm going to multiply 4 by 1/2 and then add 5 to it. And I'm going to hope that I get 7 out. Do our operations. 4 times 1/2. Okay, 4 over 1. So the 2 goes into 4 twice and into 2 once. So I'm left with 2 plus 5 is 7. And that checks out. So x equals 1/2 must be the answer to my equation.